All right, guys, complete to do now, please. All right, so first question. What do contour lines represent? We went over this yesterday. Why is there only one hand raised? Melissa? All right, it represents, well, the distance between two contour lines represents change in elevation, but you're right, the contour lines represent areas of equal elevation, all right? So if a contour line is labeled 450 feet, no matter where you go on that line, it's going to be 450 feet. All right, so how do you find the distance between 2 points on a map? What specifically would you use on that map? Go ahead. No. What's that? The scale. All right, so again, the scale is going to basically use as a ratio. So for every 1 inch on this map equals maybe 200 miles on Earth's surface. Third question, what does the topographic map show us? It's the same people, guys. The surface features in the area, whether it's mountains, valleys, depressions. All right, good. So to move on, so if you haven't already done so, please open up your notes. The last thing we talked about yesterday were contour lines. And again, whoops. All right, so copy this down. As soon as you copy this down, I'm going to go over it and explain to you how to find the contour interval. So a contour interval of a map is basically what is the difference in elevation as I go from one line to the next. So a lot of every single map that I'll give you, you're going to be asked a question, what is the contour interval for this map? Sometimes it'll tell you on the bottom of the map, sometimes it won't. So you have to be able to figure it out. So you have to find an index contour. An index contour, I don't know if you can see it well from where you're sitting, but actually you have the same map on your notes. The index contours are thicker, they're bold, and they are labeled with the elevation. But you notice that not every single line is labeled with the elevation. So what you have, so index contours are every fifth line, right? Every fifth line is going to be labeled. So we have to figure out what is the value of each line. So you have to find the value of 2. You need to find 2 index contours. I have 2,200 feet here, 2,400 feet here. All right? So what is 2,400 minus 2,200? What is 24 minus 22? 200, right? And how many lines do I have an index contour? Every 5. Good, Arlene. So what I do is I take that 200 and I divide 5 into it. So what's 200 divided by 5? Everybody's sitting here thinking, and Melissa's going old school with the pencil and paper. 40, thank you. So what you do is you now plug that in to see if it works. So 2,200, 2,240, 2,280, 2,320, 2,360, 2,400. So that's my contour interval for this map is 40 feet. every line is worth 40 feet. All right? So again, you need to find two index contours. You need to subtract them and divide by 5. That'll give you your contour interval for the map. Now, some maps you're not going to be able to find two labeled index contours. It may only have one, but it is surrounded by water. So what would that line there that's surrounded by water be? What would its elevation be? If it's at the beach? 0. So now because it is surrounded by water, I know what that contour line is. So I can label it 0. Now I have my two index contours. All right, so these are the rules for contour lines. Copy them and then I'll go over it. I think the bottom got cut off a little. All right, so these are the rules that have to be followed when working with topographic maps. First of all, two lines can never cross. Why? How can you have two different elevations at the same point? You can't. There's only one elevation at one given point. So contour lines cannot cross. So when they meet together at a single point, up here. So again, when you see, oops, there we go. When you see this happening, you see how all these lines are converging at a single point? All these elevations coming together at once, that indicates a cliff. All right? So where they all meet at that single point, that's going to be a cliff. Now, the closer they are together, as compared to the further apart they are, let's say each line is worth 20 feet, right? 20, 40, 60, 80. I have 80 feet of elevation here in a short distance. That indicates a steep cliff. The further apart they are, I have 80 feet here, but it's at a further distance. So that is a more gradual of a slope. That's what I was talking about yesterday. I don't know if it was with this class or another class, that for somebody who is an avid hiker, they'll want to work on a side of a mountain or something that has these type of spacing in the lines because they know it's a more gradual slope. They want to avoid this, the very, very steep slopes. All right? Does everybody understand that? Closer they are together, the steeper the slope. The further apart they are, the more gradual the slope. I don't even know if this video is worth it. I don't remember what it is. Find that.
Congratulations on successfully downloading the Distance Learning Day presentation. We're going to talk about topographic maps today, guys. If you want to kind of follow along in your book, that's fine, but there's plenty of things to keep your attention.
All right, you know what? Instead of wasting it.
Congratulations on successfully.
Instead of wasting our time in that, let's go to our first practice map, which is this one. All right, because again, tomorrow when we meet virtually, this is what we're going to be doing. We'll do a map together, and I'm going to give you another map to do on your own for the remainder of the time. So this one I have on paper. So again, this is what you're going to see, and this is what you're going to see on the test or quiz that I decided yet.
The test or is it the quiz?
I don't know yet. Still debating. All right. I'm leaning towards quiz, but we'll see.
It's right up there with how many.
All right, so now, so here, what you have to do is you have to find the contour interval for this map here before you start, because again, it's not giving it to you on this map. So what is the contour interval of this map? So we have to find two values. What are my two values on this map? I need to find two index contours, lines that are labeled. What are two lines that are labeled? Jafar?
One letter A says 25.
Okay, so we have one index contour that is, 25, which is right here. Do you have another one? Remember, I just said it moments ago that some maps may not give you two index contours, but you can look at other features in the area and come up with the second one. What do you see on the outside of this map? It's labeled. What? Water. So what can I assume? 0. So that line that is surrounded by the water, this over here, 2, 0, is going to be 0. So now I have my two values. So what do I do with those two numbers now? I have my two numbers. What's the next step? Remember, I said find two numbers, subtract them. So 25 minus 0 is?
25.
Very good. So now what's the next step? I have my number, 25. What do I do with 25 now? You subtract and you do this next. Divide by 5. So what's 25 divided by 5? 5. Let's see if it works. 0, 5, 10, 15, 20, 25. So my contour interval for this map is 25.
I would label all the lines on the map.
Now, the second question is asking, what is the magnetic declination of this map? In other words, what the magnetic declination is what is the difference between true north and magnetic north for that map? So I want you to look at the map and see where you can see something representing north and magnetic north. It's using the initials, not the whole word.
Then you have the scale.
Yeah. What is that? What number does that have right next to it?
7 degrees.
7 degrees. That's my magnetic declination. You look for that little compass there. All right. So when it asks you for the magnetic declination, you look for that compass, and it's going to give you your answer in degrees. So your magnetic declination for this map is 7 degrees. All right. So I'm going to give you a few minutes to attempt to complete the rest of this on your own. And with I am going to go over it before you leave here. So go ahead, work on this. So you're working on 3 and then through 5, because 6 I have to go over with you how to calculate that. It's represented by the letter J, which is over here. Answer? Arlene? A building. Good. What is represented by the letter S? The letter S, which is right here. Melissa? A river. Good. What is represented by the letter K, which is up here? The letter K. Jafar? Church. Good. What about the letter R? These are where the lines are intersecting, meeting at one point. I said that was a what, Arlene? Cliff. Good. What about the letter C? Letter C, where you are now. Christian? No. What is represented by the letter C? The school. Very good. What is represented by the letter D, which is over here? Letter D. Melissa? A bridge. Good. What about the letter X? Letter X. It's in the key. Nobody? A depression. When you see those dashed lines, that means you're going down in elevation, not up. So it's a depression. Good. And the letter A, which is not on the key. That would represent a hilltop. The innermost circle would be the top. All right? All right. What is the highest possible elevation of location A? Now, this is where students kind of struggle. So look up here. Pay close attention. So we know that the contour interval for this map is 5. They're asking for the highest possible elevation at this point, right? So what's the elevation of this line right here? 30. Good. Now, if I put another line in there, what would that be? 35, but I can't do that. So what's the highest number I can go to without hitting 35? 34. Highest possible elevation is 34. Because it can't be 35. If it was 35, I would have another line. I can't do that, but I can go as high as 34. So highest possible elevation in location A is 34. What is the lowest possible elevation at location X? We know that this line here is 15. Whoops. What would this line here be? What? This line's 15. What? 10. Why it's not 20? Because it's a depression. We're going down now. So this is 10. What would that next line be? 5. Good. Now, what if I drew another line in here? What would that be? 0. How low can I go before I hit 0? 1. My lowest possible elevation at that point is 1. Very good. It's going a lot smoother. Letter F. What is the elevation at letter F, which is right here? 5. Very good, Arlene. That would be 5 because we know that outer line is 0. Good. What is the elevation at location K, which is right here? We know this is 15. We know this is 10. So any number in between 15 and 10. 13, 12, 11, just as long as it's not 10 or 15 because it's not on the line. What about letter W, which is right here on that separate island? What's the elevation? There's a number there. 8. When you see that, that is a benchmark. They're giving you exact elevation at that point. Everybody sees that, right? 8. All right, now gradient. All right, so gradient, it says what is the gradient between E and F? So here is, let me erase this. Here is E, here is F. So the gradient is the change in elevation. So what is the change in elevation from here to here? How many feet? We know that the contour interval is 5 feet. From here to here, 5, 10. So the change in elevation is 10. Now I have to figure out the distance between the 2 points. So I'm going to use the scale at the bottom of the map, which is right here. So use a piece of paper. From E to F is right here. So when I put it on the map, wait a minute, the size of the paper is, let me do that again. EF is right here. So that's about 1.5 miles. So what you have to do now, so I know that the distance between the 2 points is 1.5 miles. I know that the difference in elevation is 10. So what is 10 divided by 1.5? Nobody has a calculator anymore. What did she say? That, yeah, to the nearest tenth though. So that would be whatever she said, 6 point. Give me the first number. What? 6.6? So 6.6 feet per mile. That would be the gradient. So again, the gradient is the difference in elevation divided by the distance between the 2 points.